there are not a lot of good diagnostic assessments, and Jim Minstrel and his group have been working on this for some time. If you look at diagnoser.com, you can find they have the facets in a number of areas. They're now working on a project. Jim is working with Angela DeBarger at SRI on doing facets for chemistry. This is secondary chemistry. So you can find initial elicitation assessments. You can find examples of facet assessments. And you can find, if you're a teacher, you can find question sets and assignments that are keyed to the different facets. So you can find ones that fit the particular student or students that you're worried about based on the facet clusters. So here, there's some about atoms, and they also have open-ended questions like drawing a picture of an atom and labeling the parts. So this is a nice resource if you're interested in science, and it's online, and it's got that careful diagnostic aspect of it, and I won't go through all these. And I'm going to skip this too. Okay, so now I wanted to move to the issue of, I'm going to take another example. This is another online assessment system. This one was developed at Worcester Polytechnic and Carnegie Mellon University, and it's also in mathematics. Now you're wondering, you may be wondering why I have so many examples in math and science. And I would say that's because in most of my examples are American. And in the United States, the National Science Foundation has funded this kind of research and development. And there has been no funding in other content areas. And that's why we don't have these examples in other content areas. That was a matter of, I guess, if you will, national policy, although I think it was inadvertent rather than thoughtful. But this system I wanted to talk about a little bit. What they did was, it's an online learning system. How many of you are familiar with the cognitive tutors from Carnegie Mellon? Have you heard of those? No? Not familiar? Okay. John Anderson, a professor there, has a carefully worked out theory of learning, and for several decades now they've been developing intelligent tutoring systems in a variety of subject areas, all math and science though, I think. But you know, there's algebra, there's geometry, there's statistics, I believe, and I think there's some science topics. And so students are doing this learning online, and one of the things about the intelligent tutoring systems is they're carefully selected problems, and the problems students get are different for different students depending on how they responded. So kind of like we saw in the assessment case with the facets instruction, depending on how you respond to a question, you'll get different future learning experiences. You also get, for example, in this case, you have the two triangles are congruent. You know, one side is x, one side is 2x. The hypotenuse, what is it right now? So it's 8 inches. The perimeter of ABC is 23 inches. What's the length of side DF in triangle DEF? Now, depending on what the student does, they can get hints. And they can be kind of walked through the problem, like what is the length of the side DF in triangle DEF, which side of the triangle ABC is the same length, and so on. So they're kind of walked through the problem. And what the system does is it allows students to ask for hints if they feel they need them. It also learns over time, working with a particular student, how much support they need. And the interesting thing about this assessment system is they took kind of the Carnegie Mellon tutor, and they're using this with middle school students. They added on to it data mining, where they went through the students, all the information that the system collects about the student's need for hints, the number of problems they try to solve in a certain number of minutes, how many they got right, what scaffolds they had, And from that, they actually used that as an assessment. They created mathematics scores based on this interaction with the simulation. Now, the thing that is interesting about this is it actually is operational. It's being used with 4,000 students in Worcester, Massachusetts. But the thing that's interesting about it is, remember I raised that issue of validity? Can you show that the assessment actually predicts something on the outside that you care about? Well, if you're in Worcester, Massachusetts and you have No Child Left Behind as your federal education policy, you do care about how students do on the state achievement test at the end of the year. And the interesting thing was Worcester, Massachusetts brought in this assessments tutoring system for its students because it thought it would help them learn mathematics. But they were a little worried about how they would do on the paper and pencil state test at the end of the year. So just to kind of make sure that everything was okay, they bought these commercial tests that are being sold a lot in the United States. They're called benchmark tests. So they'll test students like 6 weeks in the year, 12 weeks, 18 weeks, 24 weeks. It's designed to predict how well each student will do on the test at the end of the year. So that's what the benchmark test is for, to kind of see how students are doing. So those are being very popular because people are worried about the end of the year test. And it turns out that the scores they got with the assessment system, the assessment embedded in the instruction, predicted the end of the year achievement better than the commercial test that was sold for that purpose. That's kind of a complex statement. Does that make sense? So here there was this commercial test being sold to predict end of year performance that was being given, stop learning now, we're going to take this test to predict your end of year performance. And it turns out that they could just use what was in the assessment system. So what's significant about this project is that it poses the question, if we get really good at these embedded assessments that are embedded in our online learning, at some point, do we need to have those drop-in from the sky assessments at the end of the year? Or could we at least reduce the number of them? In Worcester, they found they didn't need to have the benchmark assessments. They could get rid of them. And if you stop and think about it, drop-in from the sky assessments take time out from learning. As we stop learning now, we're going to be doing testing. And how much time do you want to spend doing that? I think we've reached the limits of that in the United States. In my state, and the states differ, but in my state, starting in second grade, it's something like 15 to 20 hours of assessment. No, it can't be that. It must be 15 hours of assessment. We make every student do every spring. And then when you start adding the number of hours they spend practicing for those assessments, teachers are feeling they don't have any time to do instruction because we're always either taking an assessment or practicing for the assessment. And if we can actually have the assessment occur during the course of learning, then we don't need to have so many special occasions. And this also can affect, it also going back to, remember we talked about reliability? Because one of the things that makes a measurement unreliable is when you only do it once. So when you only, you only ask one question about whatever the concept is. You'll get a much more stable measure if you ask 10 questions than if you ask one, but it takes 10 times as long to ask 10 questions. And if you have 50 concepts you want to test and you wanted to ask 10 questions of each one, that would be 500 questions. It gets to be a long time, and if it's your drop-in from the sky external assessment, you're spending all this time being assessed. But if the assessment and the learning are actually together, you'll never notice that you're answering 500 questions. You'll just think you're exploring River City or doing a role play of genetic counseling, but you're actually making 500 moves that can be part of an assessment.